Okay, here we go. A little bit more a quick overview on the actual fracture stimulation itself. And then we're going to look into some drilling techniques here. So this is a quick overview. Take a look at it. Different proprietary technique here. This has the grommets that swell, or what they call a fracking disc. And here's your vertical application as well as a horizontal application. Actually use some of the techniques we're going to do with Google Earth here and the National Geological Society with earthquakes. Pollution of the groundwater, the aquifer, is one of the major issues. And you notice that the cementing and maybe even triple and quadruple pipe cemented in place. A lot of these casings are 20 inches in diameter at the top until they get below the aquifer, and they end up as small as 4 inches in diameter at a horizontal reach of 4,000 feet. Comes the plug, perforated pipe, explosions to cause the fractured fissures. Remember that you can drill in opposite or multi directions horizontally underneath once you get down there to the shale layer. We're looking at the cross section of the piping. And one thing you want to take a quick look at here is this nanotech. It's a polyethylene liner of sorts to lubricate, diminish friction. Some pretty gnarly stuff that they're finding in this fracking fluid, huh? They're tending to get away from the corrosive aspect of fracturing and more into the mechanical jacking or leverage expansion characteristics. That's where the Calgon bath oil beads come in. You end up with a toxic lagoon like this here. This can be reused also if it's not too depleted as far as acetic what the pH of the depends on the type of rock they're in. That potential for pollution of the groundwater actually comes from the surface water storage. Here's the nanotech we're talking about. Actual retrieval at microscopic and even at atomic levels. Bonding. And then drilling techniques also. Out comes the oil and gas, right? Man-made fractures can create a pathway for methane to rise towards the surface, which is another issue as far as carbon. Can make a huge carbon footprint, pollute aquifers. Saw the pictures of the guys back east lighting up their well water. It actually had enough methane in it that it would burn. We're going to actually look at different. There's a Halliburton cement that is pretty good stuff. It doesn't fracture like this because of the heat and the pressures exerted upon it, and the acidic nature of some of the chemicals underground tend to deteriorate the cement used in the pipes, and then you get this issue of bypass. Now, something like this happens and you got a major issue, because you're not going to be able to, we're not going to fix anything like that in our lifetime. Just an interesting fact, that your largest organ is your skin, and so all that surface area, the showering, is where most of the damage is done when you have chlorine or methane or other chemicals in your water. Certainly methane at certain levels is an explosion hazard. So what we're going to see here with some of the drilling, that we're going to see some actual drilling techniques. So the question remains, is fracking for enhanced geothermal systems, what's different about it? Is fracking for enhanced geothermal systems the same as fracking for natural gas? You see here that geothermal wells are traditionally drilled in locations where hot rock is located near the surface of the earth, and permeable rock may make it easy for underground liquid to heat up. Some hot rock formations have the potential to produce energy but lack either the necessary permeable rock or underground water to produce steam. EGS makes it possible to create fissures in the rock and inject water underground. This process can transform many potential sites into working geothermal wells. Little thermography here. We're looking at heat, right? From space, thermographic imagery. There's some pretty cool ones like that in too, some thermographic imagery from the Google Earth. Step one, you got to identify the site. After geological, geochemical, and geophysical surveys are performed, exploratory wells are drilled to determine if a site will work for EGS. Exploratory wells. It is important to determine if there are heat, fracture, and underground water present. Microseismicity. Something we're going to talk about in the next few weeks. Very important for this. Need to create a reservoir. Once they've determined the site is going to be okay, they get the injection wells drilled. Injection of water will result in the stimulation of existing fractures by causing them to slip and open. New fractures are also created, expanding the amount of permeable rock. And these are micro earthquakes, that are created. So there's microseismicity, and that's how they actually determine the size of the fractured reservoir, by listening and hearing the rock talk. So they create a reservoir. That water is heated underground by the hot rock, and the production wells move the hot water to the surface. So you lose some heat on the way up, but it's there's plenty of heat down there. Probably looking at 150, 200 degrees centigrade, some as high as 300 degrees centigrade. So we got to create a reservoir in step 2. Step 3, we're going to get the power plant operation and reservoir maintenance. So, and you see the injection well, the blue arrows going down, and then you see the recovery or the production well, hot coming up, the red arrows. In a binary power plant, the hot water from a production well passes through a heat exchanger, where it heats a working fluid that then boils. The vapor from the working fluid then passes through a turbine generator to create electricity. So you avoid the potential for contamination from the earth fluids and replenish those fluids by re-injecting them. Diminishes the potential for pollution also. The working fluid is then cooled by a condenser and reused again. The water that was used to heat the working fluid is recycled into the reservoir through the injection well. EGS can be expanded by adding additional production and injection wells. There is no loss of steam pressure when adding new wells. Adding wells increases power generation capabilities. The benefits of EGS development. Increased domestic energy production by tapping new resources, produces renewable energy around the clock, good base load, creates environmentally friendly green jobs. It's kind of scary to the petrochemical and some of these other guys that want to burn stuff. It occurs to me that the future of fracking for geothermal resources is not that promising, that we have plenty of wells and infrastructure already in place, and we can just simply repurpose the existing petroleum and gas wells that have been exhausted. The petroleum, the gas has been evacuated. They've capped them off and walked away. It's a hazardous waste that can be recycled. All we have to do is drill our production wells or drill another well into the reservoir to tap and harvest that at earth temperature, especially in binary systems like we just saw there.